Alright, so in today's geometry notes, we're going to be looking at the section titled, it's kind of hard to see here, thanks to the printer, Congruent Segments and Angles. We're going to go through this pretty quickly because it's a lot of just definitions. Finding the length of a segment is my first part here, and all it is the distance between any 2 points is the result of the difference between the coordinates. So the distance is just whatever the distance, the distance between 2 points is just whatever the difference between their coordinates are. So for example, if I look at what the length of BC is, the distance between points B and point C, well, here it's just 2 jumps, or I could have said, well, C is at point 3, B is at point 1, I can find the difference, 3 minus 1, and that will be the distance. So here my distance is 2. I will leave these 2 questions as a chance for you to get some practice. Let's keep moving on to the next part. Congruent segments are segments that have the same length. In the diagram below, PQ is equal to RS. So you're allowed to write this, which says, here, don't forget, if it has no line over it, it's just saying the length, the distance between P and Q and the distance between R and S. Here I'm writing line segment PQ is congruent to line segment RS. And congruence we'll be talking about more in this class, but what you need to know is just that congruence means 2 figures that have the exact same measure in every single way. This is read as PQ is line segment PQ is congruent to segment RS. We use a thing called tick marks or hash marks to show congruent segments. All that is if I know that 2 line segments are congruent, I can put a little tick mark on each of them, and that lets me know that PQ with 1 tick mark is congruent to RS, which also has 1 tick mark. Moving right along, we've got, I'm going to zoom in for each one, I guess. We've got midpoint down here. The midpoint of M of AB is the point that bisects, which means to divide a segment into 2 congruent segments. So if you're a bisector, you cut a segment into 2 equal parts. So the midpoint M of AB is the point that bisects the congruent segments. Or, instead of saying bisects, it divides the segment into 2 congruent segments. And I can say, well, if M is the midpoint, then AM is equal to MB, because it cut it into 2 equal parts. And following those tick marks from above, I can say AM is equal to MB. Now, for example, if this whole thing over here is 6, and M is the midpoint, well, then I cut it into 2 equal parts. That means that AM is going to be 3, and MB over here is also going to be 3. Let's move on to the next page. Dun, dun, dun. I'll leave this as an example for you to work on in class. This as well we'll talk about. Let's just get through these definitions in this video. All right. A segment bisector is any point, line segment, sorry about my handwriting. Ooh, I have to zoom out enough that you can see the whole sentence at least. Any point, line segment, or line that intersects a segment at its midpoint. So we said if you bisect, it means you're cutting something into 2 equal parts. If you're a segment bisector, you're something, a point, line, segment, or line, that hits a segment, intersects a segment, exactly at its midpoint. And that means that if I am a segment bisector, I divide a segment into 2 equal parts at that midpoint. If I was going to draw a bisector for this midpoint, notice draw, we'll talk about construct a little bit in the future. Maybe right around here would be my midpoint. And so here's a line that intersects. Here's a line that is bisecting it. Notice that it can be kind of diagonal to it. It doesn't need to be making a right angle kind of a nice corner. As long as you're hitting the midpoint, you are a bisector. All right, let's take a look, continue with these notes. Dun, dun, dun. All right. This is an important part. Hopefully you'll be able to see this on your own packet a little bit better. Let's try and read it though, here. In order for you to say that point B is between 2 points A and C, all 3 points must lie on the same line. And that also means then that AB plus BC equals AC. So all that's saying is that if I'm going to say that B is between A and C, that means that they are collinear. And if they're collinear, well then this part, AB plus that part, BC, those two lengths must add up to equal the entire length of the whole thing, AC. That's about it for our vocabulary on segments today. I want to move right along to just some information about angles. And then we'll finish up this video and you'll get a chance to practice. An angle is a set of points that is the union of two rays having the same starting point. Well, actually, I think on array you actually call this the end point, start or end point, whatever you want to call it. And we call this shared start point for an angle. This is called the vertex of that angle. Dun dun dun. All right. The set of all points between the sides of the angles is called the interior of the angle. So right over here, here's between the two sides. This is the interior of it. The exterior is the set of all points that are outside. So all the points out here that are on the outside of that angle is my exterior. Dun, 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 dun. Here's an important point for naming angles. Here, you might want to just call this angle B because my vertex is B. There's no other angle there. But if you have angles that are next to each other, like let's say I put another angle over here or another ray over here and call this D. Now if you said angle B, are you talking about this part over here or are you talking about that part over there? So that's where this definition comes in, or this kind of explanation. When you have several angles with the same vertex, and the vertex in this case is point B, it's just the shared endpoint for the rays that are making our angles, we must use 3 letters, or maybe an indicated number if they have a little arc there and they have a number next to it. They're saying that angle 1 means this part over here. We must use 3 letters or that number to name an angle. So for example, here I cannot just call this angle B if I want to talk about this angle 1 over here. I would call it angle ABC. I start with one part of the ray, go down to the vertex, over to the other part, and it just kind of makes this little slice of pie. That would be the name of it. If I wanted to name this angle over here between the DB ray, or the BD ray and the BA ray, if I wanted to name that one, I could also use 3 letters. This would be called angle DBA. All right. Continuing a little example over here, we would call this angle to the right. There's a lot of different names you can call this. Either I can call it angle ABC like we saw above, angle ABC, angle CBA, or because it has a little number in there, I could just call this angle 1. But you should not call it by the vertex because we might have a situation that happens like up here. All right, let's move right along. I want to take maybe only 1 more minute for the rest of these definitions and then we'll get a chance to do some practice. All right, A right angle is an angle whose degree measure is 90 degrees. So here, right over here, is a right angle. An acute angle is an angle whose degree measure is less than 90 degrees. And if you want, you can say less than 90. Moving right along. An obtuse angle is an angle whose degree measure is more than 90 and less than 180 degrees. So in other words, if I have an obtuse angle, it should be more than 90 degrees, but less than 180. This is OB for obtuse angle. This is what an obtuse angle would end up looking like. And then finally, for the notes here, a straight angle is an angle whose degree measure is formed by two opposite rays, and that measures 180 degrees. Let's move on to one final definition. Congruent angles, by the way, are very similar to congruent lengths. They measure the same arc. They measure the same degrees between each of them. So the rays go on forever. All that matters is how much space is between here and between here. If these measures are the same, the angles are congruent. I said final before. This is actually the very, very final definition over here. A bisector. Bisector, you can either bisect an angle or you can bisect a line segment. We already saw a bisector for a line segment. So here, just as an official definition for this, I can say a bisector is a line that divides an angle or line segment into two congruent angles, or again, if it was a line segment, or line segments. So for example, here I've got a line segment AB. Notice I can't use CD because that is a line. You can't cut infinity in half. AB is a line segment, and so the line CD bisects line segment AB. And again, notice, by the way, that line CD has the arrows above it. Line segment AB is a line segment. And then here I can say this ray QS bisects angle PQR. Angle PQR. All right, and that are the notes for today's lesson.